Welcome everybody to our February 2023 Akka.net community stand-up. My name is Aaron Standard, and I'm here with Gregorius Sodharmo on our team. Hey, Gregorius, how are you doing?
Pretty good. Thanks for asking. How about you?
Good, good. You were just mentioning that the release we just did brand new releases of Akka.Management and Akka.Hosting like 30 minutes before our meeting today, and you mentioned that the release notes look a little weird. Yeah, there's apparently a
hmm
bug in our Azure, or not Azure, our GitHub action for Akka.Hosting. So we'll have to get that fixed. That's all that is. So this is we haven't had a lot of time pass between this and our January meeting. Because I think we did that one a week late, and February is also just happens to start on a Wednesday. So we're doing these ones kind of close together, but nevertheless, we're keeping with the schedule that we started last year. So we should go ahead and probably start by diving into some of our recent Akka.net releases. So Gregorius, why don't you go ahead and take us through these first few on the list here?
there's not a lot of changes on these releases, but there are some major bug fixes. For Kafka, we finally reached RTM. So the versioning now actually is in step lock with our Akka.net version. So don't be surprised if the version actually jumps from 1.2.2 to 1.4.49
Yeah,
because 1.4.49 is our Akka.net version now.
and this is part of a new versioning strategy that we're trying to do to make things simpler for Akka.net users, which is all of the plugins. We're going to do this with Akka.Management, Akka.Hosting, and Akka.Healthcheck soon as well. We're just kind of smoothing out some of the dings and dents with those. Since those plugins are, even though they're stable and out of beta, they're still relatively new. So we're finding lots of small bugs that have to get fixed as people start really trying to use them. But basically, what we're going to try to do is sync all of our packages on the Akka.net version number. So if you want to go ahead and basically figure out which version of Akka.net does this align to, just like how you can for Akka.Persistence plugins and like logging plugins like Serialog, you can just check the version number and go, okay, this works. This is designed to work with this version of Akka.net. And because of our binary compatibility guarantees that we make, you can be reasonably sure that anything using at least the same minor version is going to be binary compatible. So we're trying to do this to help simplify things for users a bit. So that's kind of the significance of Akka.Streams.Kafka here. This is one of the first plugins we've kind of brought up to code in that respect. And then next, we have a couple of Akka.Management, Akka.Hosting releases.
Mm,
So you just went ahead and pushed Akka.Management 1.02 like literally 30 minutes ago. If I go drill into that
yep.
real quick. Yeah. So basically published this one even after I sort of finalized the release notes. These, do you want to talk us through these bug fixes real quick and what the significance of them are?
Uh, yeah, well, there's not a lot of stuff. For Akka management, it's mostly fixes for coordination to Azure, the lease implementation for Azure. And right now, all it is just fixing some of the bugs that our users found since the actual release on January. We clean up a lot of the code and basically remove all of the noise from the plugin. So hopefully it is a lot more useful now.
Yep. We're basically just kind of in a bit of like, that 1.0.01 sort of release cycle after you do a major release. We're basically doing that with all three of these plugins right now. With Akka.Hosting, for instance, I added a bug. I added a feature for solving a specific type of issue we'll get into in the show and tell presentation. We also put a new release, Akka.net 1.5, out there. So this is basically just kind of taking all of the new developments that have been done since the previous alpha, and we're putting that out there. There's a whole bunch of different changes, and I'm not going to go through all of them. We also had another stable release of Akka.net 1.4. These included a bunch of API changes that is basically designed to make it a little bit more dynamic to work with stashing, is kind of what's going on here. We also fixed one pretty critical bug with Akka.Persistence.SQL.Common and a very old but also somewhat critical bug with how pool routers restart. In any previous version of Akka.net, when one child in a pool router throws an exception, the entire pool router will get rebooted and all the children will get killed when that happens. That was basically built. That bug came about as a result of a misunderstanding of how the escalate directive worked. We've since changed this, so if one child fails, only that child gets restarted. So that's actually a pretty significant bug fix there. So I definitely recommend upgrading to 1.449. Otherwise, there's really no major changes here. The next thing we should talk a bit about as far as our stand-up's concerned is upcoming Akka.net releases. I'll start with the first one here, which is our .NET new templates that we are working on for Akka.net users, because actually going to be demoing the ones that I've been developing so far today as part of our presentation. Um, so basically, what we're trying to create here are some templates that are different. So Petabridge has been shipping a number of Petabridge.net new templates, and these are what we use for creating brand new open source projects. Akka.Hosting is actually built on top of one of them. And those come with like these big heavy duty build systems, documentation, code signing, all the stuff we need to do to kind of ship professional grade open source. And while that's been very useful for us, we've had some comments back from users that those are kind of onerous. So we're working on trying to produce some simpler templates that are a little bit more parameterizable and are also 100% centered around Akka.Hosting. So we're in the process of developing these now. This template I built so far that I'm going to be demoing today is reasonably complete. However, I haven't actually done the templating part of it yet. So I've got a bit more work to do there still. I'm hoping to have these out in the next couple of weeks. And these should also, by the way, make it easier to get your head wrapped around some of the code we're going to be showing in our Akka.Management and Akka.Hosting presentation today. Um, Alpakka RTM. Gregorius, do you kind of want to briefly touch on what we're trying to accomplish here?
Yeah, Alpaca has been in beta for forever, basically.
Yeah, like
It's
3 years. Yeah.
yeah,
Or
it's
longer
it's
than that, even.
almost yeah, it almost rivals Google, like policy on being beta forever. So we think that it's actually time for actually releasing it as an RTM. A lot of users actually uses it, and it's been used in production for years. So yeah.
So Alpacas are a set of all of our Akka Streams connectors for things like Azure Service Bus, Amazon SQS, that type of thing. And these have been, and RabbitMQ is probably the most heavily used one, and they've been around for forever. And we do have thousands of people using them. And the reason why these have been in beta for so long is this originally started as a community driven project, and no one really wanted to take responsibility for all the commitments that come with like having a production sort of ready label attached to it. Well, we moved it back into the main Akka.net project maybe 18 months ago, maybe 2 years ago. And Gregorius has been steadily chipping away at trying to harden some of those plugins, make them more robust, make them kind of aligned with the way we expect the rest of Akka.net to work. And we figure, you know what, these we should probably just take them out of beta so people will actually start using them even more, give us more feedback, more bug reports, and we can go ahead and kind of improve our cycle time around this stuff. So that's the goal behind that. Lastly, we have Akka.net 1.5. That should be shipped in about 20 days. The last big outstanding pieces we're working on around it right now. So I mentioned in our last stand-up, we moved some things out of the roadmap. The last outstanding things that we're working on here is Akka.Persistence.Link to DB. This is designed to make CQRS much less expensive to implement inside all these SQL-based plugins. That's one big change that's happening still, and Gregorius is that's kind of his full-time project at the moment. I have a couple of things I need to finish, namely we are adding some support for, well, we're trying to add some support for semantic logging in Akka.net 1.5. That's something I'm working on. We have a feature called Watch Async that allow you to asynchronously watch actors terminate from outside the actor system. That's going to have a lot of useful applications if you're trying to build more like client server type systems. And then finally, we're also kind of working on a pull based methodology for reliable delivery, kind of similar to what working with something like Kafka looks like. That's kind of the gist of things that are left outstanding right now, plus a handful of other pieces of API cleanup. I've been basically delayed on starting with this because I just had a new kid a week ago, and then on top of that, we just had a huge backlog of actual customer work we had to do, which we're finally, I think, clearing this week. So that's what's going on there. We expect this to be shipped by the end of February. Our March community stand-up presentation might be me going through some of the big features in core Akka.NET 1.5. In particular, the upgrades to the sharding system are particularly important. So we'll probably touch on that. But otherwise, without any further ado, I guess we should probably get started on our show and tell presentation. That sound good to you, Gregorius?
Mhm. Sounds good to me.
All right, so we're going to go ahead and fire up our show and tell presentation, which I'm going to be doing this week. So let's go ahead and dive right in. In fact, actually, before I do that, let me get rid of this stupid banner in StreamYard. All right, there we go. Okay, cool. Akka.NET 1.5, no HOCON, no Lighthouse, no problem. And let me get rid of this as well. All right, so we're going to cover a variety of things today. Namely, we're going to start with probably the most significant part of the 1.5 release, which is Akka hosting. This is going to permeate everything in the Akka.NET ecosystem. One of our other big projects we're going to have to do immediately following the release of Akka.NET 1.5 is basically rewrite our documentation, tutorials, Akka.NET Bootcamp, our examples to use it everywhere. And you'll see why and what the benefits are as I kind of dive into the material here. But basically, what Akka hosting is a means by which we can greatly simplify and standardize the way Akka.NET's configured. It improves Akka.NET's sort of extensibility and its ability to tie into things like Microsoft.extensions. And on top of that, it actually makes DI support, particularly between Akka.NET and other non-Akka.NET components. The example we're going to use is ASP.NET in here. It makes DI way easier to sort of work from both inside and outside the actor system. So the real theme of Akka.NET's 1.5 is basically trying to reduce friction for existing users of the technology. We're trying to make things easier for people who've been using Akka.NET for years. It'll also make things easier for new users, don't get me wrong. But this is basically a collection of what I call paper cuts. These are small friction points that piss users off over the course of working with Akka.NET. And we've tried to address as many of them as we can do. So that's why you haven't seen a lot of big Akka.NET 1.5 releases on the core Akka.NET library itself. It's largely been kind of the supporting infrastructure around it we've been working on. So in this case, cleaning up dependency injection, logging, configuration, that's what Akka hosting really does. Next, we'll talk into Akka.Healthcheck, making it easier to kind of monitor the health of your Akka.NET services. That's another piece of feedback we received. And so Akka.Healthcheck ships with a number of different liveness and readiness probes. I'll explain what those terms mean when we get to that section. But it also, more importantly, integrates with Microsoft.extensions.health So now, if you want to have ASP.NET Health Checks and Akka.NET Health Checks all kind of running as part of the same background service, that is trivial to do now as part of Akka.Health Check. And then finally, Akka.Management. This has been probably one of the biggest pain points I hear about since I'm kind of the one responsible for a lot of the core design and development on Akka.Cluster. People are not thrilled with using Lighthouse, namely because it's just a piece of infrastructure you have to provision resources for. If Lighthouse isn't available, it can't always be that it's not always that easy to get your cluster back online. So Gregorius, this is his baby, this project has been diligently working for about a year on providing us with a really robust cluster bootstrapping and pluggable service discovery system for forming clusters on the fly. So we're going to spend a bit of time covering that as well. Uh, Now, the first thing I want to dive into is probably the most significant, which is Akka hosting. And Akka hosting has got a lot of different little bells and whistles on it, but I promise adopting it and moving away from the old sort of ways we used to manage the actor system will greatly improve your experience working with Akka.NET, as well as make it easier for other members of your team to reason about Akka.NET as well. So to use Akka.Hosting, I'm just going to, for this example, install the Akka.Cluster.Hosting package. This automatically brings in Akka.Cluster, Akka.Remote. It brings in cluster sharding and persistence as well. And we have a number of different packages that all support hosting. You can kind of look for the .hosting prefix. This means that all these packages are built to configure something in Akka.NET using Microsoft.extensions.hosting. That's sort of what the gist of this naming convention is. Now, this is an example of a .NET 6, or I guess in this case, .NET 7 minimal API inside ASP.NET. This is how easy it is to go ahead and get Akka.NET up and running now. I am going to go ahead and basically fire up a, looks like we got someone spamming chat here. All right, done. Um, Basically, I go ahead and I fire up a web application builder. I pass in my configuration sources just like any other version of Microsoft.extensions.configuration. And then down here, I call configure web API Akka. This is a little static extension method I wrote that provides access to the Akka configuration builder, which is what we use to go ahead and instantiate and manage actors. And then I have a couple of other extension methods down here that we'll get access to. But this is all I need to go ahead and get Akka.NET up and running. Under the covers, this is kind of the key area that we're going to investigate here. This is where all the Akka.Hosting components are all integrated together. Now, the biggest difference between Akka.Hosting and everything else is the way your actor system is configured. We tried to bring everything closer to the Microsoft.extension standard here. And so what I built in this case is this is what I had been doing for some of my ASP.NET applications. For instance, I go ahead and I build a POCO class that has various configuration sections for different components of my service. So if I need to configure CDN support, or if I need to configure identity providers, I would usually go ahead and include, a C# object that would basically provide a description or maybe access to some connection strings for that data. And I would parse it from Microsoft.extensions.configuration using one of their built-in methods for doing that. Well, now you can do this for Akka.NET itself, where I'm configuring my actor system name. I have a config toggle for turning clustering on or off. I might want clustering off when I'm doing unit testing, for instance. Then I also have maybe some debug settings, like doing a config dump when the actor system boots up. And then finally down here, all of these config sections I'm referencing, remote options, cluster options, shard options, those are all actually built directly into Akka Hosting. Those are like the built-in POCO classes that Akka Hosting's methods accept for configuring things like Akka.remote, cluster sharding, etc. So my app settings.json will go ahead and mirror using this Akka settings section here, some of these same components. And so I have that, defined in my app settings.json. I have some base settings here, such as, here's the default host name and port number for Akka.remote. Here's the name of my actor system. Here's the seed nodes I'm going to try to use. Here's some of my configuration options for Akka.cluster sharding, et cetera, et cetera. When I go and I pull this in via the host builder in program.cs, I have a specific precedence that I use, and this is probably a good pattern to follow. Excuse me. I have a good pattern to sort of follow here where I bring in app settings.json first. Then I can optionally override some of the settings in app settings.json with an environment specific file if I want to. And then lastly, environment variables get the final say in my configuration. They can override anything in either of these two JSON files. So you'll see me use environment variables in my demo a little bit later, where I'm going to do that to use that to override things like I think I override the connection string that we use for connecting to Akka.persistence, for instance. So this is basically the way we can go and configure Akka.NET now. There's no real need for HOCON. What Akka.Hosting is really doing behind the scenes is synthesizing the HOCON from all these different variables. But guess what? One setting that Gregorius developed that I think is very useful is if you don't want to define your own little POCO classes for specifying configuration, and you feel pretty familiar and comfortable with HOCON directly, guess what? You can populate HOCON directly into app settings.json using the exact same sort of like a hierarchical structure that HOCON uses. You just have to kind of mimic that in JSON. And you can pass in the section that has your HOCON defined directly into the Akka configuration builder's builder to add HOCON setting, and we'll automatically parse and tokenize all the HOCON out of app settings.json and boot your application up directly that way. So that's another really convenient way of being able to go and configure Akka.NET if you don't want to. Um, and Gregorius, in my defense here, I actually didn't even know about the setting until I read your release notes or your pull request documenting it the other day. So that was a very pleasant surprise. um, but now our users all know about it too. Now, Here's the reason why I feel so strongly about Akka.Hosting and why I'm pushing it on some of my customers that we're doing like architecture review and consulting projects with right now. One of the things I've seen, I've reviewed several hundred Akka.net code bases over the past 8 years. And one thing I've seen a lot of is basically this pretty gnarly startup sort of spaghetti code around starting actors and registering DI containers and manually injecting things into HOCON. And that just seems like a sharp edge that is going to eventually get someone cut. So, what I prefer to do, and this was honestly not that easy to do before Akka.Hosting, what I prefer to do is in my shared libraries where I have actor definitions and maybe message definitions and state definitions, some of the sort of more functional parts of my application. Or you can do this as you'll see me do directly in the application itself. I build composable methods on top of Akka.Hosting so I can reuse this same function in multiple areas. For, let's say I have several different services in my cluster. All those services can call the same extension method defined in the same DLL to configure the same component the same way. So you might want to configure, for instance, your health checks the same way, or you might want to configure your logging the same way, or you might want to start a specific group of actors that need to be present on every service the same way. Akka.Hosting makes that trivial to do and it makes it type safe and consistent. And on top of that, it also makes all that behavior really easily testable, which I'll show on the next slide. So here, for instance, this is an extension method I built on top of the configuration builder. This is kind of like our equivalent of the service collection for Akka.Hosting. I also pass in a reference to the service provider. I grab a hold of my settings class. I'm creating a Akka.Cluster sharding message router and another method that you can't see right here. And if we're using clustering, I'm going to say, all right, we want to go ahead and turn on a shard region for a type counter actor. And I'm going to pass in my shard options that I parsed out of config. And I'm going to pass in my little formula for starting my entity actor right here. And then I'm also going to pass in the extractor. Done. I've got a very consistent way of configuring this code now. If clustering is turned off, I can still mimic the same way Akka.Cluster sharding kind of manages its child actors by using this generic child per entity parent. This is a specific class that's in this application. It's not part of Akka.Hosting. But I'm going to go ahead and use this. And that way I can go ahead and kind of test the exact same behavior I would have with cluster sharding without needing a cluster. And so this extension method will get called, for instance, and this is another component that's part of the Akka.Hosting sort of universe. This is called the Akka.Hosting.Test Kit, and it's really designed for integration testing, is what it's built for. In this case, I'm kind of using it a little bit more like a unit test. So this works the same way the normal kind of Akka.NET test kit does, but the difference is that under the covers, we're actually spinning up iHost, and we're calling the Akka.Hosting APIs to configure an actor system for you that is still sort of exposed via all the Akka test kit methods that we all know and love. So here, for instance, I'm going to go ahead and configure my little Akka settings class. I'm going to say we don't want clustering and our persistence mode should be in memory. That way we don't need any infrastructure, any network stuff at all in order to test our application. I'm going to add this as a singleton to my services. And then down here, I'm going to call the same configure counter actors method and the same configure persistence method that I actually use in production. This will give me code coverage over some of those production settings. Now, if I wanted to do a more full-blown integration test where I'm actually going to use a cluster and I'm actually going to use Akka.Persistence.Azure for running all of my Azure sort of persistence under the covers, I could go ahead and create an XUnit fixture that might spin up an Azurite Docker container or might go ahead and configure clustering. And I could actually use this exact same test to do that. And it would definitely still work under the covers. So being able to take your configuration, in particular for starting actors and configuring other parts of your actor system, and being able to include that directly in your test coverage is a huge advantage over the old way people used to configure Akka.net. Now, to kind of show you my code sample here, to kind of walk you through what like full composition looks like with Akka.Hosting, let me go to my program.cs real quick. Actually, let me go ahead and close all tabs to the right and program.cs is right here. And I'll zoom in a little bit. So this is my little minimal web API. I call my configure web API Akka method right here. And if I step into that, and let me close the Solution Explorer here. I'm basically binding to my service collection. I'm going to go and parse my Akka settings out of iConfiguration here and add that as a singleton. That way, all of my other downstream calls that want to get a reference to that configuration section can. And then I call services.add Akka. This is going to be the primary sort of entry point method for Akka hosting. And one of the values you have to provide when you call add Akka is the name of your actor system. So you provide that here. And then we have this little builder method that we can use to configure various parts of our actor system. So when I call configure actor system right here, I'm going to call configure loggers. I've got another slide detailing that, so I'll cover it in a minute. And then I have a method. These are all methods I wrote myself. These are my custom extension methods I was just talking about. I can configure the network, I can configure persistence, and then I can configure specific actors if I want to. So when I call configure network, I'm going to see if clustering is enabled. If it's not, we just bail out here. If it is, I'm going to pull in the remote options we pulled out of Microsoft.extensions.configuration. If Akka.Management's turned on, I've got to do a little bit of work to support that. Let me get rid of that real quick. If Akka.Management's not turned on, I'll just go ahead and call use clustering. And that's it. All the other network settings are going to be populated by whatever's in your app settings.json file or whatever. And then down here, when I call configure persistence, I have to work around a little bug with Akka.Persistence Azure right now where it's not parsing connection strings correctly. But otherwise, that's why I have this little HOCON method right here. But otherwise, what I'm doing is checking my persistence mode. If we're in memory, I just go ahead and return this function here in memory journal and memory snapshot. If I'm doing Akka.Persistence Azure, right now I'm just calling add HOCON, and I pass in these two HOCON objects here. And I say I want to append this to the end of my configuration. And then here's the same method we saw earlier for configuring our actors. So this gives me a lot of flexibility. It makes my configuration very composable, easily testable, and it's also partitioned well enough where other developers and other libraries that writing other libraries that my application references can have their own extension methods. So for instance, if I go to program.cs, you'll see I have a method here called configure petabridge.command. Well, this is going to go ahead and hide all the petabridge.command configuration stuff, which command palettes we're using. I could also do things like possibly configure, if I go down here, which endpoint we want to go ahead and bind our socket to if we wanted that to be anything other than the default. So I could go and tuck this into a separate DLL and keep it out of the same project that has my application code in it, for instance. This could be part of a web API template, a web API template dot infrastructure DLL if I wanted to. And I can still just call that function and know that it would apply a consistent set of settings to my actor system down the stream. And then finally, yeah, I wanted to give a shout out to the fact that we finally integrate properly with Microsoft.extensions.logging. This little extension method right here, add logger factory, is going to reference the iLogger factory implementation that is built into Akka hosting. This is going to make sure that all of the logs coming from built-in actors in Akka.net and anything that uses the iLogging adapter in your own actor code, 100% of that will now be piped out to whatever your logging infrastructure is that's part of the Microsoft.extensions.logging setup. So this is trivial to do. It's literally like one line of code essentially in order to get that set up. And that's built into the core Akka.Hosting library now. You can also do things like very easily add serial log support in here. In fact, while I don't have that integrated into my application, if I go and pull up the Akka.Hosting repository and we scroll down to the documentation that Gregorius painstakingly wrote, I believe as an example right here. Yeah, here you go. This is how easy it is to add serial log now. You just call add logger, serial log logger, assuming that you've referenced the akka.logging.serial log NuGet package. So it's a one-liner, way easier to set up than it used to be, and generally speaking, much less ceremony to get all this working than it used to be. So Akka.Hosting has streamlined a lot of our configuration work and a lot of our logging infrastructure. But I would say probably the newest feature since we first introduced Akka.Hosting about 10 months ago is the way we've improved the dependency injection experience for Akka.net. So Akka.dependency injection has been around for a couple of years now, and this is what ties into the Microsoft extensions.dependency injection ecosystem. We've made that something that kind of is natively built into Akka hosting now and just kind of works behind the scenes. So for instance, when I call builder.with actors, this is how you start up specific actors inside Akka Hosting. What's going to happen is you're going to get a reference to the actor system. You're going to get a reference to the actor registry, and you can also pass in a reference directly to the resolver, which is going to use the iService provider that this Akka hosting instance is connected to. So in that case, this with this little minimal ASP.NET application we're building, that's going to be the host that's built into the web application component. So I can go ahead and call system.actor of, and I can create a, this little generic child per entity parent right here. And I'm going to get a reference back to it in this little parent variable right here. And I'm going to save this reference in the Akka registry, the actor registry that's right here, when I call this register component. Well, what this will allow me to do is now I can natively inject this actor into all of the other parts of my application that might need it without needing to do any additional ceremony or setup. All I have to do is take a reference to I required actor. This is an interface built into Akka Hosting, and I need to pass in a generic type in here. In this case, that type is going to be the exact same type I used to save this actor into the registry. That's going to tell the Microsoft.extensions.di system to resolve the actor that's in this registry and populate it into the actor ref field right here. And that way I can just go ahead and interact with this actor directly inside my HTTP controller. So now the DI from outside Akka.net and the DI from inside Akka.net are basically fully traversable on either side of, let's say, the of my .NET applications now, and it's very easy to pass references around. The one little gotcha possibly with the I required actor, and this is a bug that just got reported for originally a couple weeks ago, but now there's actually a live issue for it on the Akka hosting repo. The one little bug is that if you're using something like a background service, which starts up immediately and might have dependencies injected into it immediately, the one little catch is that your actors are started asynchronously in Akka hosting by a hosted service that we use to create the actor system and run it behind the scenes. So those I required actor types aren't actually available when your background service first starts. So one thing you might need to do is pass in the actor registry directly and call actor registry.getAsync. This will give you a task you can wait on. And when that actor gets added to the registry, that task will complete, and then the rest of your background service can continue executing from that point onward. We're going to try to work on a way to make this automatically happen behind the scenes so you don't have to be aware of when the actor registry has an entry populated in it or not. But that might require doing some things like blocking on a task.result inside of here. So we're in the process of trying to see if there's a better way of doing that, but that's something that we are working on. So that's Akka.Hosting in a nutshell. And that's by far the most significant part of the whole Akka.net 1.5 development effort so far. The next piece we're going to step into is the Akka.Healthcheck library. Now, this is part of the Petabridge organization rather than the Akka.net organization. And that's because we originally built it years ago, like 3 or 4 years ago, to help some of our customers implement Kubernetes style health checks. Now, don't worry, it's all open source, it's all Apache 2. It's just that we originally published it there and we just kind of left it for the time being. So in case you go looking for that repo in the Akka.net organization, you won't find it. You want to look in the Petabridge one. But what Akka.Healthcheck allows us to do is have Kubernetes style liveness checks. Liveness checks are pretty black and white. If a liveness check fails, you're signaling to Kubernetes or whoever is listening, if it's not Kubernetes, that this process needs to be killed and restarted. This would be a critical failure of some type. If the liveness check passes, it means this process is running and is presumably healthy. Readiness checks are a little bit more subtle. This is basically a load balancer health check. And so the distinction here is that the process might be live, but it may not be ready to receive traffic from live end users yet. So a good example of that might be before we are able to begin receiving traffic from live end users, we need to ensure that we've successfully joined an Akka.net cluster. Without that, we may not be able to do our jobs properly. That's an example of a readiness check that's actually built directly into Akka Health Checks if you want. Now, if a application persistently fails a readiness check over a long period of time, let's say 30 to 60 seconds, that'll basically amount to the same type of condition as a liveness check failing. So that's something to be aware of. And it's basically kind of meant to say, you know what, you should be able to get ready to serve traffic in a relatively short window of time. If you can't do that, we're going to need to basically have you restart and get recreated. So, what does Akka.Healthcheck allow us to monitor out of the box? Well, for liveness checks, we have several different probes. We have one that basically checks to see if the actor system started. Obviously, if Akka.net's not available, that's going to be a problem. So we'll go ahead and fail that liveness check if the actor system's unavailable. Probably the most useful one overall is the Akka.Persistence check. I'm particularly proud of the design of this one. This works using what we call a suicide probe, where basically it writes a record to the journal and will also record a snapshot, and it'll kill itself and then try to recover the exact same data that it just persisted, and then it will delete it from the journal and the snapshot store. If any one of those steps fails, the Akka.Persistence liveness check is going to fail. So this is meant to make sure that your database, whatever it is available. Then for Akka.Cluster, the liveness check is basically whether or not we've successfully joined a cluster. Now, when a process is first starting, usually there's a grace period where it's not going to nuke you the very first time you fail a liveness check. That would be kind of brittle. It's going to give you a bit of a grace period. You should be able to join a cluster within 10 to 20 seconds when you first boot up, even if you're using something like Akka.Management. So that's sort of what the idea is behind these. For our readiness checks, we basically have the same sort of conditions the liveness check has. Plus, we also check to see if all the other nodes in the cluster are unreachable. We're going to assume that we are in a losing side of the network partition, and we're going to mark ourselves as not ready anymore. It's also quite easy to customize Akka.Healthcheck probes if you want. There's just a little interface, well, basically a little base class you have to subclass from, and a little bit of work to go and configure it. But you could do things like check to see if an application specific actor is available or not, or if a cluster singleton is on a node that's reachable or unreachable. Those are all sorts of things you could do. So these are kind of the built-in targets that Akka.Healthcheck exposes. In addition to having health check targets, so the targets are things you need to check, transports are the way you tell the systems monitoring you how to check your health. We have four options that are built into Akka Health Check. First is we have programmatic health check, where you can basically subscribe to health check updates from any one of the probes for each of those different targets. And that's done programmatically. So that might be useful if you want to be able to react to a failing liveness or readiness check without your external sort of infrastructure doing it for you. We also have a TCP socket mode. This is basically opens and closes a socket depending on whether or not the check succeeds or fails. We also have a file health check, which will go ahead and read and write to a file, depending on whether the system is healthy or not. And that's typically used in combination with a command line execution health check. This is like a Kubernetes thing. Probably the most popular, and this is the newest one we've just added as part of the Akka hosting effort, is integration with Microsoft.extensions.health checks and the health check service that is built into that library. This will allow you to expose the health of your Akka.net applications via an HTTP endpoint, one of the Health Z endpoints, if you want. That endpoint name can be customized, but Health Z is what it defaults to. So to install this, there's a few different Akka Health Check packages. If you install Akka Health Check.Hosting.web, this will pull in all of them, and this will also give you the integration with Microsoft.extensions.health check. So we're going to pull this in, and then to configure our application, there's three things you have to do, unfortunately. The first thing you need to do is call this extension method right here with Akka Health Check, and this specifies of all the available health checks, which ones do you want to use? Gregorius, correct me if I'm wrong, but this supports this is like a bit mask, right?
Yes, it is.
Yeah. So you can basically go ahead and toggle different ones on or off on here if you want to. I'm just defaulting to all in this case. So you got to do that. This actually starts the health check service and registers the Akka.net health checks with Microsoft.extensions.health check. So that's what this does. Next, we have to register the same health checks that are being queried by Microsoft. We also have to register them with Akka.net. And then finally, we have to expose the health check HTTP endpoint on ASP.NET somewhere. And that's what this final setting does. And I customized the response writer right here to basically write out a little human readable JSON payload of what the status of each of these health checks are. That'll make it a little bit easier for me to debug what's going on inside my system if I just want to eyeball it real quick and I don't feel like getting Postman or Fiddler up and running. This is what the HTTP sort of response output for a healthy system looks like right now. I can see that our basic Akka.NET node is alive. We can see the Akka.NET node is ready. We can see the cluster is alive, cluster's ready, and we can see the Akka.Persistence is alive as well. And we can see these subchecks all passing down here as well. Journal recovered, snapshot recovered, journal persisted, snapshot persisted. If one of these checks failed, the service would be marked as unhealthy. So, and by the way, if one of these failing, it usually means you've got database problems, and you're going to want to be notified about that sooner rather than later. And when I do my live demo, we'll go ahead and hit this endpoint again. But in the essence, the long and the short of it is this is the default endpoint that's going to tell you the sum total of how healthy your application is at any given time. So that's Akka.Healthcheck in a nutshell. The last big feature area we'll touch on, and probably my personal favorite, since this kind of deals much more closely with Akka.Cluster specifically, is Akka.Management. Akka.Management is designed at reducing pain around the formation and running of clusters, is what it's designed to do. So, Akka.Management is fundamentally a cluster bootstrapping and seed node discovery system. Each node is going to expose a non-public HTTP API. One thing we explicitly did with Akka.Management by design, and no, we're not going to reverse it, is we made it so Akka.Management runs on a totally separate HTTP kernel from ASP.NET. The reason is that you do not want, under any circumstances, a user to be able to do things like force your node to leave the cluster by hitting an HTTP endpoint. So we decided that in order to make this as safe as possible, we needed to go ahead and basically separate those two. So it exposes a non-public, lightweight HTTP API that's basically just using an HTTP listener under the covers. And each node is equipped with an Akka Discovery plugin that allows them to basically query which nodes are available to form a cluster and also to add themselves as one of the nodes that might want to participate in this sort of transaction. And once the minimum quorum gets reached, the default value is 3 nodes. Once a minimum quorum is reached, a cluster will be formed. Now, if any of the nodes are currently part of a cluster, the very first node that reports back that it's in a cluster to whoever's trying to join, the joining node will simply just join the cluster they're already a part of. So it helps ensure that it's still very frictionless to go ahead and join new clusters as well. Now, why does this exist and why is it helpful? The biggest benefit of this is it avoids the missing seed node cluster join problem. This is one of the shortcomings that Lighthouse tried to avoid, but sometimes you can't, which is that, let's say, for instance, I have 3 Lighthouse nodes and 2 of them are unavailable and the third one is rebooting. Well, that would mean that no one would be able to join a cluster if we needed to try to roll out, let's say, an emergency deployment or a rollback inside our system. And that's currently a bit of a headache for a lot of users. What this tool, Akka.Management, provides is a way to circumvent that problem entirely, where seed nodes are dynamic, they're not static anymore. So any 3 nodes can be my seed nodes. So Lighthouse really has no future in an environment where Akka.Management is now kind of the key driver of cluster behavior inside the system. So it avoids the missing seed node problem. And generally speaking, it makes it much safer to deal with production issues, such as I'll give you a really common one. Probably the most common type of severe production issue that people with really large clusters run into is when there's something going wrong with their hypervisor. So if you're running, let's say, 200 Akka.NET nodes on a public cloud or on a self-managed, let's say, VMware system, well, when the hypervisor is running out of resources, let's say just because the underlying hardware is really busy, or maybe there's actually a software problem with like the network software-based network address translation, that can cause nodes to rapidly shift from being reachable, unreachable, and so forth. That's going to be the type of problem where you'll be really glad Akka.Management's there instead of seed nodes, because in the event that your 3 Lighthouse nodes get isolated, You don't need to worry about them anymore. Any three nodes will do. And Akka management is very consistent about making sure only a single cluster forms. We've been able to validate that with some pretty rigorous stress testing on clusters up to 400 nodes in size. So we know for certain this works well at scale. The way Akka management fundamentally works under the covers is like, why does this HTTP API exist? Basically, the first thing we start with, we have three different nodes here that are not part of a cluster. Let's say I've done a brand new Kubernetes rollout of a stateful set that has Akka.NET in it. No one's part of a cluster just yet, but everyone's listening on port 8808 for incoming Akka management HTTP requests. And we're going to use Akka.Discovery.Azure as our service discovery engine. Well, the first thing each of these nodes are going to do is they're going to populate Akka Discovery with their own entries. They're going to say, I am running on node 8081, and I am part of this service name in Akka Management. And here's the Akka Management port you can use to contact me. That's all going to get populated into these entries. And each of these nodes, in addition to populating their own entries, are going to periodically query Akka.Discovery.Azure for entries for other nodes. We're going to do that until we form a cluster, is what's going to happen. So whenever I get a set of entries back, let's say I get a entry for myself and two more nodes in the cluster, bearing in mind that our minimum quorum to form a new cluster is 3 nodes. What I'm going to do once I get those nodes back is I'm going to send an HTTP request to the management endpoints for all the other nodes I discovered inside this discovery list. And then I'm going to collect all the responses back from those nodes and determine, is this node already in a cluster, or is this node alive if it's not in a cluster currently? If this node's already part of a cluster, I can just issue a join command to that node and join that cluster immediately. I don't have to wait for any more responses at that point. So that will allow me to go ahead and very quickly join an existing cluster if I want to. But if nobody's in a cluster, what I'm going to do is say, okay, I need at least 3 contact points in order to form a cluster. After I've received those contact points, I'm going to send some HTTP post requests to all the different Akka management endpoints, instructing them that you need to go ahead and form a cluster with this node, and this node. And all these nodes of running Akka management will all agree. And then what will happen is a cluster will begin to form, and they'll change their own HTTP outputs next time a fourth node comes up to join them, indicating that I am already part of a cluster, but you could join it as well if you want to. So that's sort of how the Akka.cluster bootstrapping process works in theory behind the scenes. And the real key driver behind it is the Akka.discovery engine that we're using. So we have, I think, 5 options for discovery today. Akka.Discovery.Azure, which, by the way, this will actually work even with non-Azure workloads. This basically just uses Azure table storage to do service discovery behind the scenes. So I'm actually using that inside Docker Compose for today's demo. And I can even use it on Visual Studio and my desktop if I want to, using something like the Azure Storage Emulator or Azurite if I wanted to. Next, we have Akka.Discovery.Kubernetes. This will use Kubernetes features like namespaces and pod labels to go ahead and find appropriate pods to connect to form a cluster. We also have some Amazon Web Services specific plugins for things like EC2 and ECS. These use a combination of tags and some configuration values to determine which ports to go and contact these nodes on. And then finally, we have Akka.Discovery.Configuration, which works very similarly to seed nodes, but the key difference is there's no more special rules around this first seed node in the seed node list having to be available anymore. It's going to still use this dynamic HTTP querying process to figure out who can I form a cluster with and how can I go about joining one as quickly as possible. So to install this into your own application, you really only need a couple of NuGet packages. First is Akka Management, and then you need, Akka Management's the first one you need. And then the second package you need is whatever your preferred discovery plugin is. The configuration discovery is built into Akka Discovery by default, so that's already included in Akka Management. But for our purposes today, we're going to use the table storage discovery. So that's going to be the package I reference here. And then I just need to do a little bit of Akka.Hosting to actually configure all of this. So I'm going to go ahead and call with Akka Management. That turns on my HTTP API. Then I'm going to turn on with cluster bootstrap. This is going to specify the metadata I'm going to look for how to go about forming this cluster. And it's also going to be what starts the actors that are responsible for sending messages to the Akka.Management API to make all this happen. So I just need to pass in these settings here. And then I need to configure down below my discovery component with Azure Discovery. The way we synchronize the cluster bootstrapping and the discovery system is through the service name. In theory, with Akka Discovery, you can actually use it to discover multiple types of things all at the same time. Akka.Cluster is the only system we're using it for currently. But at some point in the future, we might use Akka Discovery for being able to discover Kafka nodes, for instance, for Akka.Streams.Kafka. At some point down the road, we're also looking at maybe building a gRPC based version of the cluster client. We might use Akka Discovery for doing that type of thing as well, potentially. It really depends a bit on whether that would make sense. But the service name is there for situations where Akka Discovery can be used to find multiple things all inside the same system. So that's why the service name is important. That piece of metadata is going to identify which keys in Akka Discovery the bootstrapping process is going to be interested in. And it's also used when we send an HTTP request to the Bootstrap API. That's going to determine what type of data you get back as well. So these keys need to be in sync. Otherwise, the rest of this is all fairly independent from each other. This other setting down here, required contact points number, this is going to be the setting that determines how many nodes need to be online in order for us to form a cluster for the very first time. That defaults to 3, and 3 is a pretty safe default, so I'd continue to use that. Now we're going to do a little demo and actually see how all this works. So first thing I'll do is I'll pull up my Akka.net/Akka.net templates. These are going to be the new .NET New templates that we're working on. Strongly encourage you guys to follow this repo and give it a star if you want to. We're going to use the web API template right here. So I'm going to pull this up in Writer, and I'll get my Solution Explorer back out. Let's see if I can pin this here. All right. So basically the way our solution is organized in here, just to kind of give you a little overview, we have a couple of new new .NET features we're taking advantage of, such as we're using centralized package management, and we're also taking advantage of package source mapping, and we're also using the brand new .NET SDK Docker support as well, which I'll probably cover that in its own video eventually. But basically, we have our domain folder. This has all of my events, which I organize into commands, events, and queries. I won't waste time diving into that right now, but these are basically just all of the different parts of our system. In my web API template.app, I have a folder for configuration, another one for controllers, and then I have my actors folder in here. And the actor that's going to drive most of the behavior in the system is our counter actor, which is a basic persistent actor here. And I won't spend much time going on the actor design, but basically it's going to process I counter commands, and it's going to produce I counter events, and it's going to serve data in response to I counter queries. That's what we have going on there. And then in my controller, I basically have an HTTP API that can be used to query the current value of a counter, one that can be used to increment a counter's value, and another that can be used to reset the counter's value altogether. We're going to use Swagger to play around with that a little bit in just a second. I'm pulling in this I required actor right here to go ahead and inject this actor into all of my HTTP methods on this controller. And then in my program.cs, I'm just going to configure my Microsoft.extensions.config. I'm going to configure my actor system here, and then I'm going to add controller support here. And that's going to be the gist of all of our little settings here so far. The real key thing that's going to drive most of the behavior of this system is going to be this configure web API Akka method, which we've already taken a look at. Basically, we're going to end up using clustering and cluster sharding to manage all these counter actors. Now, if I pull up my little Docker Compose file that I wrote here, let's see, it should be in the Docker folder. We're going to use Azurite. If you're not familiar with that, this is basically a Docker container that can be used to emulate all the different parts of Azure storage. So that's Azure Table Storage, queues, and blobs. So we're going to use that as our Akka.Persistence target and our Akka Discovery target as well. I have one special node here that's going to publicly expose petabridge.command as well as our web API. That way I can actually demo it for you on the host machine. And then we're going to have 3 replicas of our little Docker image that we're building. And I'm going to override the connection string to point to Azurite. And I'm also going to override the Akka.Management port and the Akka.Remote port as well for this system. And the host name is going to be determined by dns.getHostName. That's going to be how this is configured. I'm also going to set the ASP.NET Core environment equivalent to Azure. That is going to have me load this environment setting right here, which is going to have me turn on Azure Table Storage for discovery and Azure Table Storage for persistence. So I'm using the same sort of modular practices you would use for testing multiple environments in ASP.NET. I can now very easily do the same with Akka.NET. That was not necessarily true all that long ago. So let me go ahead and do this first. I think I've taken down, let me go ahead and do Docker Compose down real fast just to delete everything. Perfect. I have a little bash file in here I'm going to run, build docker.command. This is pretty cool, this little feature. It's going to build a Docker image without a Docker file, believe it or not. That is using, if I look at this real fast, that's using these brand new properties that are built into MS Build. If you're using the .NET 7 .NET 7 SDK, and you also need to install a little package right here. The where is it? Microsoft.net.build.containers will let you do that. I'll talk about that in another YouTube video in the not too distant future. But that'll allow me to go ahead and build my Docker images without needing to write a Docker file. And it'll use the version number of my assembly to populate the Docker image tags. So that's all up and running now using the latest. I'll call Docker Compose up down here. So this should start by creating Azurite first, which I actually need for everything else I'm going to do today. I can see Azurite's running, and then it should start the rest of my system. All right. And if I do this, PBM cluster show, it looks like we're still in the process of forming our cluster right here. But if I do this one more time, everybody will be marked as up. And this is without using seed nodes of any kind. So let me go ahead and enter interactive mode here. Now, next thing I'll take a look at is our cluster sharding data. So we have this counter region. Let's take a look. Looks like there are no shards, no entities for the counter region so far. Okay, so we haven't actually populated any data yet. We'll fix that in just a minute. Let me go ahead and pull up in Docker here. Let me grab the PBM host container. And I think we're running on port 8080. All right, let me go ahead and pull up our health check first so we can see that working live. I'll go to localhost 8080/health disease/Akka. We can see the Akka.persistence is working, and we can see that we're in a cluster. So I can use this data. I already used petabridge.command to kind of verify it, but I could also use my health check to verify that we have formed a cluster and the Akka.persistence is working. So everything started correctly inside Docker Compose. That's fantastic. Next thing we'll do is we'll head over to Swagger real quick. All right. So these are all my little HTTP APIs that I exposed earlier. So let's take a look at my little counter setup right here. And let's see if we have a counter called foo. Execute. And I'll get back that we got a current value of 0. So there's no counter data there. If I go to petabridge.command and rerun this query, we'll see that there's now 1 shard and 1 entity available. So this allocated a shard when we actually ran that query. If I go down to my little HTTP post method right here, which is going to allow me to update an existing counter's value, or if there's never been a counter before, it'll create it on the fly, update it from 0. We'll go ahead and call a counter called bar, and we'll populate this with a value of 10 initially. And I'll hit execute. And you'll see that we get back that we incremented by 10 and the new value is 10. If I hit execute again, that value will be 20, then 30, 40, 50, etc. And all that is responding pretty snappily, I might add. And if I run my little query down here one more time in petabridge.command, we should see there's maybe 2 shards now. And sure enough, yes, there's 2 shards and 2 entities spread out across the cluster. So this is actually querying a remote node somewhere else in the cluster. So there's real Akka.remote overhead involved here. Now I'll go ahead and try out one more counter with our put method. This is going to assign a counter a value right out of the gate. Houston, in honor of you, I'm going to go ahead and use your handle here, H3 Tech. We'll assign you a value of 12, and I'll get back the new value is 12. Then I'll go ahead and grow this to 144. Go ahead and use some powers of 2 here. And now the new value is set to 144. So everything's all working hunkodorily under the covers here with a fairly minimal amount of work. So we're able to dynamically change the way our application runs by using some configuration toggles I built into my Akka settings class. We're able to set those values using a combination of environment files and environment variables if we want to. And then on top of that, it's very easy for us to integrate our actors with ASP.NET. Last two things I'll go ahead and demo real fast. Let's talk about unit tests. This is using the Akka.Hosting test kit, and I'm basically doing a little unit test where uh, my little method down here, configure counter actors, is going to automatically spin up the actors behind the scenes for me, and I have access to them right away from my application starts. I'm just going to send an actor with a dynamic ID, this sequence of messages, and at the very end, in order to make sure that all the messages got processed, the counter value should be equal to the sum of all these different changes here. So let me run this real quick. And you'll see that this will all work behind the scenes as well. Ta-da, that worked. Now, one thing I could do if I wanted to is I could actually go ahead and use the ASP.NET test host here, and I could actually do an HTTP query against my live controllers and do an end-to-end integration test really easily with Akka.NET. And Akka.NET can be running in a cluster, it could be running with as a solo process, or it could be running with in-memory persistence or real persistence. It wouldn't matter in any case. I could very easily integrate that and mock that without having to write a bunch of really complex fixtures or mocks to do it. Akka hosting makes it very easy to bring all the infrastructure to each individual test. And on top of that, the Akka hosting test kit makes it very easy to incorporate that into individual unit test classes without a lot of ceremony either. So you should definitely check that out. The last feature we'll touch on, we're not going to demo it because it's kind of advanced. The last feature that's part of Akka.Management that we've spent a lot of time and energy working on is called Akka.Coordination. This is going to play a bigger role for larger clusters probably, but it can still work for small clusters too. This is a distributed lock implementation. It's designed to help multiple processes settle disputes over who's responsible for what inside a distributed system. So in the case of Akka.NET, probably the most valuable area where it's going to get used is split brain resolvers. In the event that, let's say, there's a lot of instability where you don't have clean partitions, instead you might have dozens of small partitions happening all over the cluster. The lease-based implementation. These are so Akka.Coordination creates what's called leases. That's our name for a distributed lock. Whoever owns the lease gets to decide who gets killed in the cluster, basically. So it's very effective at being able to resolve split brains in really big clusters. That's one benefit of it. The other benefit is that it can be used to decide who really owns a cluster singleton. It kind of gives us a more explicit way of being able to allocate that responsibility, and also can be used for determining where shards should be allocated inside our system. We have a user right now that is allocating about 600 shards using one of these. And we've been working with him to debug a couple of issues surrounding that. I believe that distributed locks, while they're very cool and fun, probably aren't practical for small clusters because you really don't have that much of a surface area where responsibilities can get kind of disputed or confused. But for clusters that have 100 plus nodes, I actually think they're very helpful. So we'll probably be looking at using them inside applications that are about that size going forward. And in terms of implementations, like how do we actually go about implementing these distributed locks? These require, oops, I guess I duplicated a slide there. Sorry about that. We basically have two different sort of production worthy implementations today. One uses Azure Blob Storage. So we have a lease implementation that touches that. We also have another one that uses a Kubernetes custom resource definition. We have used both of these at a fairly significant scale. They both work. We are in the process of trying to troubleshoot a couple of issues around the Azure implementation right now. That's those releases of Akka Management that Gregorius spoke about earlier. But that's kind of the gist of everything that we've been working on as part of 1.5 so far. All of these packages have stable APIs, so you should go out and start using them. We've already started fielding a bunch of questions about these inside the Akka Discord, so that's great. We'd love to see more of that. But generally speaking, we think that the combination of Akka hosting plus health check and management will greatly improve your developer experience. It'll make it easier to reason about your code, and it'll also help solve a lot of other pain points, particularly where integration with the rest of the .NET ecosystem is concerned. Gregorius, is there anything that I failed to mention in this presentation that we should cover real briefly?
No, that's pretty much it.
Good. Okay.
Yeah.
Well, that'll do it for this month's presentation. Now, we're still looking for some show and tell speakers for March, April, and May. So, if any of you are interested in sharing your story about how your company or your project leverages Akka.net, please go ahead and contact us. We would love to make that happen. They're a really great way for you to go ahead and give back to the community. And they're also a great way to attract developers who'd be interested in working on Akka.net projects to your company as well. So thank you very much for your time this month. We really appreciate it. And hopefully next month, we'll be demoing all of the brand new Akka.net 1.5 core features as well. So thanks for your time today, everybody, and we'll see you next time.